morning, everybody. Today we have Fraction Operation Unit Study Guide. So, in the first part it says I can find the greatest common factor and least common multiple. I eliminated number 1, so I'm going to move on to number 2. It says find the least common multiple of 8 and 12. Well, if you have to find the multiples of 8, that means you are going to be multiplying it. So, for example, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So you can look at it that way, that the first box is being multiplied by 1, and the second box is being multiplied by 2, and the third box is being multiplied by 3. Also remember, multiplication is also repeated addition, so you can look at it another way. You can say 8 plus 0 is 8, and 8 plus 8 is 16, and 16 plus 8 is 24. So your job is to fill in the rest of these multiples. And then what you're going to be doing is finding the least common number between these numbers, 8 and 12. So after you're done listing the multiples, find the number they have in common, that's the least, and that'll be your least common multiple. Alright, for number 3, I eliminated it. Number 4, you have to find the greatest common factor between 80 and 50. And what I have done here is created a factor tree and a Venn diagram to find the greatest common factor. This is not my favorite way to find the greatest common factor, but it is a strategy, so I just wanted to review that. So for the greatest common factor, you can make a factor tree for 80, and when you are factoring 80, you're basically asking yourself, what multiplication sentence can I use to make 80? So in this case, I used 10 times 8. After you're done factoring that one, you have to factor these other numbers. So what's another multiplication sentence I can use that'll equal 10? Well, I did 2 times 5. Another multiplication sentence that'll equal 8 is 2 times 4. Now I have to factor 4. So I can do 2 times 2. Basically, you keep factoring until you get prime numbers. All right, there are two kinds of numbers. There are prime, and then there are composite numbers that we have reviewed. And prime numbers are numbers in which only have factors of 1 and itself. So, for example, 5 is a prime number because the only numbers that can be multiplied together to equal 5 are 1 and 5. But a composite number, for example, would be 10, because the factors of 10 would be 1 and 10, and also 2 and 5. So a prime number is only prime if it can be multiplied by 1 and itself. It is composite if it has more factors than just 1 and itself. Alright, so what I've done here is shown you how to do a factor tree. Alright, so again for 56 I have to find a multiplication sentence that will equal 56, so I did 7 times 8. 7 is prime, so I don't have to factor that further. But 8 is composite, so I can factor that more. So 2 times 4, and 4 is also composite, so I can factor that one out to be 2 times 2. Now there's a bunch of colors here, and they all mean different things. So I went ahead and created this Venn diagram as the strategy, and the numbers they have in common, when you multiply them together, will give you your greatest common factor. So the numbers in the middle are the numbers they have in common. And the numbers on the outside are the numbers they don't have in common. Okay? By the way, only prime numbers go in this Venn diagram. So the middle are the prime numbers they have in common, and on the outside are the prime numbers they do not have in common. So it's pretty easy to see that 5 is a number they don't have in common. There's only 5 on this side. There is not another 5 on this side. So 5 is a prime number for 80, and 7 is a prime number for 56. Now, you do see that I have a bunch of 2's, and why didn't I include all of those 2's in the middle? Well, I only have to take the prime numbers that they have in common from that are the lowest on the tree. So for this side, for example, that I'm pointing to here, 2 is the lowest prime number on this side of the tree. Branches, that is prime, and they're shared in common. So 2 is a number that they share in common. Okay? And 2 on this side is a number they share in common, so the 2's go there. And then for 56, this 2 would go there. Now, I didn't use this 2 because I've already used a 2 on this line. I didn't use 2 here because I've already used a 2 on this line. Okay, I didn't use this 2 because, again, it's on that same line. But I did use this 2. All right, and even though it's on the same line, it is the only 2 that's a prime factor for 56, so I had to use it. Very confusing, not my favorite strategy. For number 5, I'm going to scroll back up to a previous lesson to show you a different way to find greatest common factor, and this is the way I was taught. This is my favorite way. So I'm going to scroll on up to the top here. Hopefully I can find it. This is, I believe, day 2. Here it is. So on the day 2 worksheet for factors and multiples, or day 1, I'm not really sure. Pretty sure it's day 1. I did the factor tree example already. And then this is one of my favorite examples. So you can list the factors of 16 and then list the factors of 20. All right, I put them in order from least to greatest, and I find the ones that they have in common. And of course, it's the greatest common. So the greatest common factor here for 16 and 20 is 4. What I did here with the little arches and the multiplication signs is I'm just showing you that it's 1 times 16 gives me 16, 2 times 8 gives me 16, and 4 times 4 gives me 16. And the same on the bottom for 20. 1 times 20 gives me 20, and 2 times 10 gives me 20, and 4 times 5 gives me 20. The next example down here, you can list the factors for 24 and 40, find the numbers they have in common, and state the highest common factor to represent the greatest common factor. If you don't know how to find factors of a number, okay, again, you're going to need to look that up on your own on YouTube because we have gone over that already, or Google it. But if you do have Siri or an Alexa, you can ask the say, Alexa, what are the factors of 24?
24's factors are 1, 2, 3, 4, 6, 8, 12, and 24.
All right. Scroll back down to the part of the worksheet that is probably my my least favorite when we are modeling division of fractions. Here we go. All right, so for number 7, we have a whole number being divided by 1/3. So I get an answer of 12, and here's how I got my answer. What I have here is 4 whole pieces, and I've cut them into thirds. So this is 1/3, here's another third, and another third. They want to know how many thirds fit into 4. So I'm taking 4, and I'm dividing it, I'm splitting it into thirds. So how many thirds are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 1/3 that will fit into 4 holes. All right, number 8. A lot of lines, a little confusing, and I'm going to explain what the colors mean and what these extra boxes mean and everything. So we have 5, 6 divided by 2. That means I have to take 5, 6 and split it into 2 parts. So I've labeled my number line with 6 because that's the fraction I'm working with in its denominator. I'm going to split 5 sixths in half, so I only want to split this red section here at the top. I identified where the halfway mark was, except that there's no fraction here. So that means I have to create equivalent fractions in order to find out what half or what 5 6 split into 2 is. So I drop my line down to show where the halfway mark will be. And since I split this box in half, I'm going to split the rest of the boxes in half. So this box was split in half, and then I've done the green lines to show you that I've split the rest of the boxes in half. Now these blues are the sixths. So this whole box right here was a sixth. And those blues line match the top lines to show you that these are the same size. So I'm going to split these boxes up because that's what happened in the middle when I was trying to find the half of 5/6, or 5/6 split into 2. I split this box up, so I split the rest of the boxes up. Now I have a whole set of new fractions here, and if you need to know the denominator, your denominator is going to be the total amount of boxes that the whole has been split up into. So I have how many pieces, because the denominator is how many pieces there are in the whole. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that my denominator is going to be 12. Now, once you know what your denominators are, you know what the denominators are going to be for each of these lines. So the denominator is 12. And then how many spaces? 1, 2, 3, 4, 5. So this line right here that I wanted to identify is 5/12. So your answer is going to be 5/12. For number 9, I eliminated that problem. For number 10, we have 4/5 divided by 2. So the thing that we did here was, it was 4/5, so I created a box that was split up into fifths. There's 5 total pieces here in the box. 4 of them are shaded, and I want to split it into 2. So I want to split this into 2. And now I've created a new set of boxes. I've split up more boxes in my square here. So now I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my denominator is 10. Now, in order for me to get my numerator for the quotient of this problem, I just have to count the top boxes. So the only boxes I really have to count are located on the top right here. It's all of these boxes, the ones that run across the top. Those are the only ones I need to count. All right, I'm going to circle those real quick just to show you. So the only ones I need to count are these boxes right here. So I have 1, 2, 3, 4. These 4 boxes. 4/10 will be your answer for number 10. So number 11 says write a real world problem to represent the equation below. I have 12 divided by 3/10 equals 40. Well, a real world problem might say something like this. If I had 12 feet of rope and I wanted to cut or split the pieces into 3/10 for each piece, I would get 40 total pieces. Or I could say I had 12. I could say I had a gallon of milk that had 12 cups in it, and for a recipe I only needed 3/10 of a cup. How many recipes will it make? It'll make 40 recipes using 3/10 of a cup for serving sizes when I have 12 cups of gallons of milk. There's another example. For number 12, pretty easy though. It says write an equation to represent the real world problem below. It says the area of a rectangle. By the way, area of a rectangle is length times width. That's how you find the area of a rectangle. The area of a rectangle measures 9/14 feet squared. It has the length of 3/7 of a foot and a width of 1 1/2 of a foot. So I went ahead and I color-coded these boxes here because all you're doing is writing an equation. And they gave you the 3 parts of the equation. So the yellow is the area, and as you remember, it was length times width. So the length is right here in the pink. The width is right here, width times length, or length times width, it doesn't matter. And then my product will be in yellow right here. So basically you just got to match the numbers into the colors. Pretty easy. All right, for 12 through 16, pretty simple. It's keep, change, flip time. So for those 4 problems, you will keep, change, flip those division problems to find your quotients. For 17 and 18, it's the same deal, except that I converted your mixed numbers into improper fractions for you. All right. For the following problems, I'm just going to read the problems out loud as I kind of written down the expressions or equations for each of these problems. So in number 19, it says, Chris is building a model out of wire. He has a length of wire that measures 9/10 of a yard, and he cuts it into 5 equal parts. Then how long will each piece be? Well, if I have 9/10 of a yard of 9/10 of a wire, I can split that 5 ways. So it's 9/10 divided by 5. And don't forget, a whole number as a fraction goes over 1. 20. The length of a rope measures 5 yards. Carrie would like to cut it into equal portions of 2/5 of a yard long. How many pieces will Carrie be able to cut the rope? Well, I have a rope that measures 5 yards, and I want to split it into 2/5 of a yard long. So how many pieces will I have? Now, number 20 is a great example, a great real-world example that you could use very similar to 11. It's very similar. If you look at the problems, 12 divided by 3/10 equals 40. For this one, it would be 5 divided by 2/5. So it's very similar to number 11, and here's another real-world example. I did use rope, though. For number 21, we have Chelsea is sewing homemade scarves for her sisters and friends. She has 4 5/6 yards of material and needs 7/8 of a yard for material for each scarf. How many scarves can she make with the existing material? Well, I went ahead and converted 4 5/6 into an improper fraction for you of 29 over 6, and it's being divided by 7/8 of a yard of material. So when you're done finding the quotient to this, when you're done performing your math, try to convert your improper fraction to a mixed number, and I did post a video on how to do that from Math Antics. For number 22, a carton of milk holds 10 cups. A recipe for strawberry milkshakes require 3/4 of a cup of milk. How many recipes can you make with a carton of milk? Again, very, very similar to the problem in number 11, another real-world example. So you're going to take the 10 cups and you're going to divide that 10 cups for each serving size, which is 3/4 of a cup, to tell me how many, basically how many milkshakes I can make from that carton of milk that holds 10 cups. All right, number 23. Mr. Jordan teaches a gardening class, and he finds that he has 12 1/2 pounds of soil for a project, and that project requires 7/10 of a pound. How many people can complete a project from the gardening class? Well, if I have 12 1/2 pounds of soil, and for the project I only need 7/10 of that, how many people can complete the project from the gardening class? So I wrote that problem right here, and again, you can convert your answer from an improper fraction to a mixed number. So kind of the skill I'm targeting here after you've done these problems is, can you now convert an improper fraction to a mixed number? So that's kind of like the skill I'm looking for here. For number 24, the area of a rectangular shape measures 4/7 square feet. If the length of the shape is 2/3 of a foot, then how wide is the rectangle? So go ahead and do your keep changing and flipping for that one. For that one, you're not going to get a mixed number. 25 through 27 are adding, subtracting, and multiplying fractions. You can always go back to previous videos or YouTube how to add fractions, subtract fractions, or multiply fractions. It's not something I'm going to go over in this video. For number 28 through 33, I will read you the problems and tell you the keywords that tell me the operation and what it is. So, Mr. Anderson is cutting lumber to use as a border around his garden. One length of the lumber is 2 7/8 feet long, and the second piece of lumber is 1 1/3 feet long. how much longer is the first piece than the second piece? Well, if I want to find how much longer it is, I can subtract how long the second piece is from how long the first piece was. So I can take 2 7/8, take away 1 1/3 to tell me how much longer the first piece is than the second piece. Number 29, Mrs. Smith bought 4/5 of a pound of red jelly beans, 1 2/3 pounds of green jelly beans, and 1 3/5 pounds of purple jelly beans at the grocery store. What is the total weight of Mrs. Smith's purchase? Well, we want the total weight of all the jelly beans, which means that I have to add up each bag that she bought. For number 30, your recipe requires 1 2/3 cups of sugar. If Mrs. Mariana is going to make 1/2 of the recipe, then how much sugar does she need? Well, remember that 1/2 here is written as 1/2 as a fraction, and you're going to be multiplying 1 2/3 by 1/2. Number 31, Stephanie studied for her science test for 5/6 of an hour on Monday and on Tuesday for 1/2 of an hour. How long did Stephanie study this week? So we want the total amount of time that she studied. So on Monday she studied for 5/6 of an hour. In addition to that, which is our operation, on Tuesday she studied for a half hour. So what was the total amount of time that she studied this week? Number 32, an article fills 5/8 of a magazine page. A related photo takes up 1/4 of the article. How much of the page is taken up by the photo? Right here you have a multiplication problem with fractions. 33, Trista has 3 3/4 yards of ribbon to use for making decorative pillows. If one pillow uses 2 1/6 yards of ribbon, then how much ribbon is remaining? Well, if we need to find how much ribbon is remaining, we need to subtract how big the how much ribbon they used in the second from how much she had to start with. All right. Then you have your test. So, for number 1, it says find the length of the rectangle rectangle below. So, if I need to find the length, I can take 1 2/5, which is the area, and divide it by 4/5, and that's going to tell me what the width is. For number 2, a carton of orange juice holds 10 cups, and a recipe for fruit smoothies requires 1 1/4 cups of orange juice. How many recipes can you make with the carton of orange juice? Well, I took 1 1/4 and I converted that to an improper fraction for you, and that is being divided by 5/4. I'm sorry, I took 1 1/4 and converted it to 5/4 as an improper fraction. So you take the 10 cups and you portion it out with 1 1/4 cups each time. How many recipes can you make with that? Number 3, it says, one of my favorites, it's the models. So the model below represents which of the following equations? Well, if you remember from the top, a little bit confusing. My model looks very similar to this one, but what we have here is we have 5/8 being represented right there. Now, out of that 5/8, it's being split into 2 to get a quotient of 5/16. And I eliminated an answer for you to give you a better view of what's going on. Definitely try to use the numbers in that problem to tell you what the answers are. All of these have the same numbers with the exception of A, which is 2. And don't forget that we are splitting 5/8 into 2. So, the number 4, the model represents which of the following equations? So, I have 4 pieces right here, and the pieces are being split into 2/3. So, I eliminated part B, and you can tell me which one you think it is, A, C, or D. Number 5, Jeremy is packing a stew into to-go containers. There are 5 3/4 cups of stew that will need to be put into 5 to-go containers equally. how many cups of stew will there be in each container? So I'm taking the 5 3/4 cups of stew that we had, and I need to divide it into 5 containers. So I'm taking 5 3/4 and dividing it by 5. Chelsea is sewing homemade scarves for her sister and her friends. She has 7.5 yards of material, and she needs 2 1/4 yards of material for each scarf. So how many scarves can she make with the existing material? So again, you are going to be dividing. So if I had 7.5 yards, you can divide that by 2 1/4 material to tell you how many scarves she can make. 7 through 10, very simple, just solving those math equations there. I crossed out number 11. In number 12, you have to find the least common multiple of 5 and 8 in this situation here, where it says a neighborhood trash pickup comes every 5 days, while the recycling pickup is every 8 days. After how many days will both the trash and the recycling be picked up on the same day? So the least common multiple is what you need to find out for the numbers 5 and 8. Number 13, the length of a rope measures 7 feet. Stephen would like to cut it into equal portions, which means division, of 2/3 of a foot long. How many pieces will Stephen be able to cut the rope? So I take the 7 feet, I'm going to cut it or split it or divide it by 2/3. Number 14, Kathy and Nana are working on a craft project, and Kathy would like to give these birthday presents to all of her friends. Nana has 6 2/3 yards of material. If each project requires 3/4 of a yard of material, then how many friends can she give the gifts to? So I take 6 2/3 and I converted that to an improper fraction, and I'm dividing it by the required material for the projects, 3/4. So you just have to perform this math problem right here. For number 15, it says Mr. Joseph bought 9 pounds of fertilizer for his lawn. He uses 2 2/3 pounds for his backyard and 1 2/9 pounds for his front yard. How much fertilizer is left? Well, if he used 2 2/3 pounds for his backyard and 2 2/9 pounds for his front yard, I have to add those together because that's how much soil I used. So once you add those together, you can take your sum and subtract it from what you started with. He started with 9 pounds of fertilizer, and then he used these. You take the total that he used and subtract it from what he had to get your answer. And number 16 is very similar, it's just a little bit different. Find the missing side lengths below when the perimeter is 16 feet. Well, we know what we're starting with this time. It's 16 feet. But I have to subtract the sum of all these fractions from 16 to tell me what the missing side is. So you're going to add up all the fractions, which you did in number 15 first, and then take away the sum from what you originally had, which was 16. All right, 17 through 20 is pretty self-explanatory. I want you all to have a good day and stay safe.